var v1 is no longer necessary. And var v0 is no longer necessary. I should say that completion will count as code that compiles to a matching binary. I'm not, for speedrunning, I'm not going to worry about macros and other things like that that would have to be correct to submit this back to the project. Within the project, we consider this a return value of a 32-bit. This has been an issue on other functions in this. It doesn't seem to make a difference here, so I'm not going to worry about the return value. All right, so we're looking at animation set palette. So animation set is set first. And then Z priority draw mode. And where's facing left? I think this facing left is out of order, but I'm not sure which one it is yet. I'm going to leave it there for now. Otherwise, I'm guessing that all of these are correct. It's just incorrect ordering. Let's see. We don't have any other warnings to go through. We were closer there with animation set down there. What if we move palette down? Nope. Okay, let's continue on. So we're missing a bunch of code related to the frame index, and that's because this is actually two different fields being checked and not one as the decompiler suggests. So this is going to be the animation frame index and the field right before it. No, the field right after it, animation duration. All right, that got us really close. Let's go back up here. So this is the one that's out of order. And that looks like the order that we needed, so that's great. And we're 140. I think we only have immediate values left, line 25. So these were screwed up. So it should be 5 and 1. Okay, closer. Everything else is so far looking fine. All that is fine. So we're going to take this and copy it into our project. We have a conflicting definition. I'm going to try to force this to be a 32, but we'll see if that works. And we're okay. Stop. 9 minutes and 23 seconds. So we have a world record, 9 minutes and 23 seconds to decompile one of the weapon functions. Let's see if we can beat that time. Reset the clock. I'm going to write 9:23 down. And we'll do it again. So we're going to find the next function in that list. This one's for weapon 41. If you're just tuning in, we're speed running, decompiling Symphony of the Night functions. Why? Because it's there. So here's weapon 41. We're looking at entity weapon attack, which is the main entry point. Why is this not there? Has this been decompiled already? Or did I look at the wrong weapon? Entity weapon attack on... Yes, here we go. So entity weapon attack. The rules of the speed run are I need to create a new scratch. The timer starts as soon as the scratch is created. I can't look at the assembly before I start the decompile. The decompile just needs to match. It doesn't need to be perfect and ready for PR. So I'm choosing PlayStation, Castlevania Symphony of the Night preset. I'm going to copy my assembly in. Get my timer ready. Oops. Let me switch over to the browser. So I had set up my, I've not created the scratch yet, copied and pasted my assembly in, have my context prepared. It has been modified specifically for this. I've not looked at this assembly at all. And I'm going to see how fast we can get to a matching set of code. So 3, 2, 1, go. I screwed up my paste. Resetting the timer. And I will try again. It looks like I might have gotten a character from my terminal in there. All right. 3, 2, 1, go. No. Entity weapon attack. Where? Start again. Uneventful. Working out the kinks of speedrunning decomp. My paste was wrong again. All right. Now we're good, I believe. Go. I'm not narrating these like I usually do. I'm going just as quickly as possible. But I will kind of talk about things along the way. The goal here is to get to a match as quickly as possible, not necessarily to get perfect code that's ready for check-in. So here I'm trying to figure out, I don't know offhand what these globals are going to be, what types they are. I'm just trying to get something that will be able to compile. So I can keep moving from there. So these are best guesses. And if the instructions are not correct, then they will get changed. We don't need that parens. Oops, wrong one. Okay, one more thing, line 51. That needs to be an array. All right, so we're at 75% with the decompiler. Now I'm going to go through and clean up as much as possible first, and then I will start trying to get closer to a match. Some of this will work out along the way. I know that the animation set is going to come first. Let's see. I'm going to change my player globals to struct access. These are things that likely could be a script as well, because they are pretty mechanical changes. Why did I not undo this? Line 9, I have an issue. Line 8, I have an issue. Yes, all these need to go away. This G player needs to change. Interesting. Okay, so I'll have to keep that for now. This one is going to be a little trickier. That's okay. So here, some of these are going to be out of order. Z priority is going to be down lower. It doesn't look like we need this. RA2. Odd. Perhaps we do. So this is being used to generate an index. Before we go further, let's get rid of these go-tos. That's got us a little closer. And this looks like a fall through. Is that going to be correct? Looks like it. Okay. So this function was within 100 bytes in size of the last one, and I'm guessing it's going to take slightly longer than the 9 minutes the other one took. We're getting further. That's not good. GAPI, I can get those. GAPI is accessed through a struct. Closer, good. Did I script this? Line 55. These are out of order. It's better. Yeah, I'm guessing this was supposed to be a break. Yep. Okay. 81%. Good. Did I get rid of any of these along the way? Temp V1 is gone. Temp A0. This is that. So ultimately, it's a value that's being assigned back here. Let's look at temp V1 first. No, temp V0. So this is going to be a speed index. So we're doing some calculation based on this speed x. So we'll call var a2 speed x. Sometimes I find it helpful to figure out what the code is doing to figure out how this might be structured. This seems superfluous. That is odd, so we'll have to look at that in a second. So we have an extra subtraction that's not happening on this line. Let's see if everything else has fallen into place. None of this has fallen into place yet. These look like they are going to be in the wrong order. So let's get the ordering right there. That's usually animation set, unknown 5A, palette. Animation set, unknown 5A, palette, closer, flags, Z priority, draw flags. We're not setting draw flags here. Further down, we're doing fine. And we have one case down here around line 63 where oh, forgot the break. .46. Out of order? Nope. Drat and double drat. This one might not be successful. Temp A0, we don't know what that is yet. Temp A2 is just a variation of temp A0, and we can get rid of it. Alright, so what is remaining is ordering up here. Potentially some of the shifts are going to different registers. Unknown for C is typically set after positions. That's not getting us any closer though. I might have to call Uncle on this one for a speed run. We're doing these way out of order. This 504. And 204. So this is being set much earlier than I have it. We're still pulling that 204 in. I'm I'm going to change this and see if we can force that to be later. Yes, that did it. We have immediates, so unknown 5A is getting set earlier. Not that early. Too early. We're usually animation set, unknown 5A, palette, but those are not coming up in the right order. But they're not in the right order up here either, so the order we have is palette unknown 5A animation set. That worked, so let's copy that order here. That does not. That still does not. That does. Get rid of this cast. Get rid of this cast. It's going to be plus equals. How close are we? 89%. Minus equals. Okay, down here we're still out of order. Here we're loading a 16-bit value when we should be loading a 32-bit value. So we can change this to assign 32. That fixes a bunch. Line 47. Here we are doing the same thing. That fixes sum. Line 44, subtraction is happening when none is necessary. So are we not having... This one? Nope. Oops. Not that one either. We'll have to look at what that could be. These are... So temp A is being set, and then this field is being incremented. Does that look better? No, that looks way worse. So we're at 15 minutes. Let's see if there's more obvious things to do. So we are... I'm going to take these values, put them in the context, re-decompile, and see if those fields change. So temp high, that was originally 32. There may be some size issues. Our stack is much smaller than the one that was originally there. And so why might that be? I might have to call Uncle on this one for a speed run. We can go through and figure out what the changes are, but it's not... this one I'm not going to be able to get through in any reasonable amount of time. So we'll go back through it now and look at what are the things that were causing issues. Shrink this down a little bit. So on line 27 here, we're storing a word where none is being stored. We're loading this into v1. And then later on that v1 is being, so this is likely out of order. Unknown for C, often set after Z priority. Move that down. That gets us much further away. There is, the issue is I'm treating this as an array, but it wasn't an array. It is just the value. We're going right to that address. So that was a miss early on. That's okay. We're learning. Likewise, this may not have been a array either. This may have just been a 32-bit value. We will try that. Sometimes you see patterns and it looks like they're one thing and they end up being very different. Yeah, so it looks like that one probably was an array originally. We'll back that change out. There is a significant amount of trial and error that goes into this, which is probably one reason that you don't see a lot of speedrunning decompilation happening. We're actually getting much further off, I think, than we were earlier, so I'm going to back out a bunch of these changes. And then restart. Based on what was known. Sometimes you have to go backwards when you're decompiling to move forward. In this case, I think I was choosing some suboptimal choices. So this this speedx is likely a just a 32-bit signed int. So let's look at what is going on here. So on line 27, we're loading and setting this field. This, I had a feeling, was out of order. Sometimes memory access is not in the same order as the statements are going to be in the C code. So we have to account for that. So typically Z priority is set before unknown for C, but facing left is usually set before flags, so this one might be out of order as well. Does that help? It does not help. That's going to be minus equal 4. Those don't help either. This layout is slightly odd compared to some of the other functions in this in weapons. I'm going to go through and look at places where weapons are being set to values, and oftentimes weapons that are close together work in similar ways. So this is promising. So I'll use that as my basis for what this code might look like. So setting Z priority, setting facing left, setting flags in that order, followed by unknown for C, and then the position. That cleans this up. The immediate values are a little different. That's okay right now. That may work out as we figure things out. So the speed, we're going to be taking the current speed. This is going to get set back to this value, and we're going to be, let's try doing a mod by 4. Nope, way off. This ended up not, it is an index. All right, so we are is it possible that I got these out of order? No, that seems right. Okay, let's look at these down here. This logic works, however, it doesn't seem necessary. we can increment this value beforehand, and then we don't need to use that here. I'm not sure if this is going to work out yet, but we'll see. So it's going to be a minus equals, and then we're going to increment here. And that all got us much further away. Sometimes, as you're going through decompiling, you're trying to think, how would I have programmed this if I was the original author? And then trying to reproduce that that same idea. One thing that seems like is missing is we're not incrementing the step anywhere in that first case, which seems odd. And that's because I missed it. So were I to write this code, what would it look like? Sometimes that looks very much like what you might choose to do. Other times, the original authors just had a very different style and a very different way that they were doing decomps, or sorry, not decomps, but building this originally. Their priorities were significantly different than what ours are. They were trying to get a game shipped, and we're just trying to figure out how they did it. Where is this increment happening? So there's a branch that is coming back right ahead of that step. I had gotten rid of it because this block 13 seemed superfluous. This is actually a much cleaner decompile now, though, than what was originally there. I don't see a significant difference, however, in how those two things are written. Let's see what happens if these are made closer. No, that doesn't change anything. All right, that's okay. We know that that increment has to be there. Some reason, though. And again, this could be an ordering issue. The increment on ours is happening before this load. This load is array access to offset 10. And I'm going to assume that this is happening earlier. Okay, what? And we have to use struct access to get that. That did not help. That's okay. We still have kind of a mess in two different places. And our stack size is off. I'm going to see if this offset is used in any other weapon. see that being used. So this is custom to these, at least so far, and perhaps why this hasn't been decompiled yet. This may be the time in the stream where we go look at the decomp permuter and see if the permuter is going to tell us anything. This was weapon 41. And we were looking at, and see, weapon attack. I may actually go through and see as well, has anybody else worked on this one, and how close are they? So there are 2 others that are in flight. One at 91%, we were at 93. That's looking relatively similar. And then another one that's at 68%. So these, let's look at around these middle areas. They're having the same problems. Their stack looks fine though. And this happens sometimes. You don't know why the stack is the way that it is, so you put some padding in there to make the stack work out, and sometimes that fixes registers and other things like that. And so it might not be the worst option, but not one that I like to employ if I can get rid of it. We'll try it without the pad. So I'm going to take these and we'll put this in and run the permuter and see if it gives us any ideas. This is going to fail building, but we'll go over here. And import that into the permuter. And we'll have that run for a little bit. No such file, of course. Yes, because I forgot the extension. Not .x. Alright, so here this goes. It has already found 2 things that may or may not be valuable, so we'll go look at what that is. And a much better score. So we have several of these diffs that the permuter has found. We'll look at the best one first, but the best isn't always actually what we'd want to include in our code. Okay, so it wants us to use the variable that we set earlier, fair. So this has us setting this stack variable here, and then using that So that does give us 2%. We can reuse that here as well. I'll want to go back and clean that up. I don't necessarily like that change. There's a few things here where our immediate values are different. So this is being multiplied by 2. However, due to the size of those values and the size of that array, we don't need that multiplication there. There's a subtract that, oh yeah, I was looking at this earlier. It wasn't obvious to me why we'd not want that subtract, or where the subtract might be coming from. It may be related to the shift. So we're looking at the last 5 bits, or no, we're shifting over by, no. We're shifting over by 17 bits, so looking at the high word and then one more. I'm going to tweak those a bit. No, doesn't make a difference. We can also look at what temp A0 is. Is this... Nope, it wants it to be a 32-bit, so we'll keep that. And then go back to the permuter and see what it gave us. If you're just joining the stream, I tried doing speed running of 2 different functions. The first one worked out splendidly. We got it in about 9 minutes. Which is pretty good for decompiling. This one is giving a little more problems, and I may switch over and try one more from a speedrunning perspective, because what's left here is mostly the minutia of figuring out why certain code isn't compiling the way you think it should compile. We'll save this one off and come back to it, and then try one more run. So the rules for speedrunning decompilation are, I don't get to look at the assembly except for copying and pasting it into decomp.me. I need to go from assembly to something that will compile in the project and give me a match with the retail version of Symphony of the Night for the PlayStation 1. The code does not have to be perfect or ready to be checked in to GitHub. So we're going to look at Weapon 45 for this third attempt. And we're looking at the third function here. Sometimes we can look to see if there's have there been other attempts, which is probably a good indication of whether this is a good choice for a speedrun or not. If there's been other attempts that haven't been successful, it's most likely because there's some trick that... This is Weapon 45. Some trick that is non-obvious. So there has been 2. I won't look at them. Maybe I'll look just to see if how close they are in terms of percentage. If they're similar to this other one, let's look at the next one up. See if that's any better. So this is weapon 49. So there's been one attempt here, but it looks like it is still relatively early, so we'll try that one. Let's look at 45 too. Nobody has attempted 45 yet. All right, so we'll look at weapon 45. This is an unknown weapon, which means we don't have any way to infer at the moment what this function might be doing or how it might work. We're looking at .004. Oh no, there have been people that have done this one too. Okay, what about weapon 18? All right, I think we found one. All right, so we're going to look at entity weapon attack for weapon 18, and we'll see if we can do this in 15 minutes or less. This is a longer one. It looks like the per meter is going, and it has found some things. I'm going to copy this assembly, create a new scratch, start the timer, and go. So setting up the project, disabling built-ins for GCC because they're not necessary. And then we have one variable that we don't know what it is yet, which is this GAPI function. We should know what the signature of that function is. Oh, sorry. Let's see if we can figure that out. It's a void with a 32-bit argument. And I got that from the header file that's already that already understands what that is. Other decompilers have gone through and figured out the signature there. I am going fast, but I'm going to regenerate this based on the updated context, since now we know what the signature of that file is. 72% is where we're going to start today. And first I'm going to go through and switch all my player globals to struct access. Along the way, that's going to screw up one, this gplayer 38. We're going to, that is going to be an offset into an array. But it's going to be called gplayer. Fixing up those globals, line 5 and 6, so we won't need these anymore. Okay, 74%. Now let's go through and get rid of some variables. Temp v1. is gone. Fix GAPI. Screwed something up along the way. This reference can go. At 83%. Alright, the next step is to get rid of these go-tos. So block 18 is incrementing and returning. In all cases, we're doing effectively the same thing. We're always incrementing and returning, so we will change this to an increment and return. Okay, got us to 84. Most of these won't actually need to be returns, they can be breaks. Here we'll need to reorder these, and that will give us were we already in the correct order? No, we weren't. And I believe this is animation set palette, unknown 5A. Yes. Same thing here, animation set palette, unknown 5A, that's fine. Set sprite bank, this is going to be on an array. We have a conflicting definition because I put this in the context. Get rid of these. 84%. Line 27. We're doing these in the wrong order. Flags on. This is coming later. I'm going to look up that order. Unknown 5A facing left. So unknown 4C happens after Z priority. Facing left flag Z priority draw mode. That worked out. 45. We don't need that increment anymore. We're at 90%. This one's going swimmingly. The immediates I'm not too worried about. Line 50. Alright, so we have timer is so the first something in the first 3 bits is set, or one of these other conditions holds. Often we have shifts in here that are unnecessary. I don't see that. Line 50, it's possible this is not. Okay, so basically we're saying if it's not 8. But why is it written that way? I'm not worried about that for now. We're going to skip it. Here, this is going to be a the decompiler chooses the timer member of this union, but that is not that's not what we'd probably like to use instead. So if this is equal to 0, before this gets checked in, it should be switched to use the weapon's lifetime. But we're trying to go fast, so we're going to skip that. So we're at 92%, getting closer. Here we have another one of these timer decrements, and the same idea here. So if the timer is 0, or the lifetime of this is 0, Yeah, we had a 9:23 earlier, and yeah, I think I now have the world record for recorded speedrunning time of Symphony of the Night, specifically in the weapon module. I missed my decrement. Okay, that matches. Line 70. So here we are doing a subtract on x20. And here we're doing a plus equals. That assignment's not necessary. Right. Some of these are not working out. Let's save. So we're loading Y. That works. This ends up being a plus equals. All right, that worked out. I had something off earlier, so at 96%. Let's see if we're using any of these anymore. Get rid of all that. So let's see what else is missing. A lot of immediates, line 46. Yeah, so we're back to this mess with the timer. So let's check the decompile. That says it's doing the same funny thing. So if the first 3 bits aren't set, and we're greater than 9. So not happening within the last 10 frames. But once every 15 frames, 16 frames. So this may be a mod. Let's try that. So if we're no. I'm going to look up lifetime, weapon lifetime, and see if there's any similar conditions like that. So let's try that. If we're not less than 8, less than 7, less than equal to 7. All right, so we're loading the timer. Our instructions are correct except for the shift. Let's try throwing it into a Okay, that may have helped with registers. Unsigned. It definitely does gamify it. Unfortunately, the stress of the timer does not make thinking critically about why bit shifts might be happening any easier than it normally would. So so we're doing these shifts that looking at the last 3 bits, the original was doing this and that's what we're doing. But it's not dealing with the shifts. And do we have a... Yeah. Oh, we're... Got it. So it looks like one thing I missed in the original was it's doing a comparison against no, it's loading the... So it's loading this value from the current entity, and then it's loading it again. But somehow the compiler does not think that these are the same values, and so it's loading it twice. So what would be happening that the compiler doesn't think that it can trust that the value has changed, or hasn't changed? Alright, so this is the only thing that is remaining in this particular function. So we're almost there. We just got to get past this. Let's see. So we can't be less than 7 and greater or equal to 9. So we would be wanting to do something. Let's see what weapon this is. Power of Sire. I took the shifts out of here. What if this actually needs them? We're going to go to the permuter. 19. So I'm using the permuter to try to figure out what this last conditional is, and then we'll be done. This will not beat the world record set earlier today. Thank you, permuter. You've done it already. Let's see what I was missing. I don't believe you, but I will give it a shot. So the permuter is saying load this into a separate variable, which we already have, and check that variable instead. Let's try doing it above. I'm going to keep the permuter running, and then we can check what if there is other options that it comes up with. What's odd about this solution? Okay, it did come up with something else. We'll look at that one. Anything better? Yeah, so it likes this idea of using a separate variable to access the timer, which would be how the compiler might not know that it needs to load that value twice. That seems really odd to me, though, that it would be pulled two different ways. I wonder if it's not actually the weapon here. I didn't consider that. Let's get back to this 47. So our first load for offset 7C. Now these are both coming from V0. Oh no, S0 and, yeah, S0. So it is coming from the first thing on the stack, which should be our argument. Give me something better. What else can you give me, permuter? I don't like it. It likes this idea that there is a second entity. And then we are using that entity someplace. Yeah, I don't see that working. The other odd thing is that it puts the assignment after a switch, which yeah, is an unreachable statement. So we're really just pointing it to nothing. So it does get closer, but the register it's using is wrong. And that's because the register it's using has nothing in it. But it does generate the rest of the assembly correctly, but nonsensically. Okay, so what other reasons might this have for being different and wanting to load twice? The Permeter hasn't found anything else. I'll look at some of the less likely changes there. What did I do? Anything where it's introducing a new variable I don't like. And I suppose I could turn off that. So here we have a reference to the weapon lifetime. I don't like that either, but and we're setting that right away. No, we're setting it above the case, which is again a nonsensical. It's doing the same thing. That is not a reasonable place to put that assignment. Alright, this might be fail 2 for speedrunning. We had one successful speedrun, and then we have these dopey ones that... actually, let's look at... I'm going to look at places where the lifetime is set beforehand, or the check before create entity factory from entity. The return value of create entity from entity is typically not checked in that condition. So I wonder if that is what is causing the issue. Let's try pulling that out. So that helps neither place. And nesting these does not help either. It knows better. It's almost as if this is being treated as a 32-bit value. Yes, it's being treated as a signed, sorry, not 32-bit. It's being treated as a signed value, which is going to change the way it's loaded. So we're going to load it as a 16-bit pointer, and then dereference that pointer. And will that give us the... Gives us nothing. Let's look at other entities and see if we can load that through a different field as a signed 16-bit. Oh, it is signed 16-bit, but the compiler chooses unsigned when it's masking, which is fine because it doesn't need that bit at the top. Okay. Sometimes decompiling goes like this, which is not uncommon. Something relatively mundane, like a conditional statement like this, turns into, you know, what otherwise would have been a 10-minute decompile turns into half hour or an hour, while trying to figure out what the cause of this difference is. There it is. So it wasn't looking at the timer. No, it is looking at the timer, but it's looking at it. It's looking at it in a way that so that okay, so it's accessing it through another field in this union. So we could just use timer T. Ah, drat. Timer T is... So it does look like I need to find something that is at that first offset, but is a different type. death, for example, not the best choice, but it's unknown 7C is unsigned. And so we need the, let's use the unsigned one here, and the signed one down here, and we probably can do this possibly through casting. Nope, that doesn't work either. Well, help me, Permuter. Nothing yet. I'm gonna have to step away for a second. The stream's going longer than I wanted to anyway. We're over 30 minutes, so nowhere near world record time on this one. Actually, I'll probably stop for today. If you are interested in seeing the world record for decompiling Symphony of the Night weapon code, you can go back in the stream about 15 minutes in. The world record currently is 9 minutes and 23 seconds, and I defy anybody to show me a better function decompile in the weapon overlay of Castlevania Symphony of the Night. Monday we'll be back with more decompilation. I'll probably work on these a little more and figure out what these last couple bits are and get these submitted for PR. Project Omega, I don't think you were on earlier, but we looked at randomizing within the decomp project itself and how to how things might get set up so that we can, at compile time, choose random options for starting gear, and that that ended up being a relatively easy change to make, while still being able to have the project compile back to the retail releases. So I think that's it. So some success with speedrunning, some failure with speedrunning, but that's the way live streams go sometimes. Other than that, that's it. If you're interested in the Symphony of the Night decompilation project, check out SOTN.z.dev, which has progress for the modules. A lot of work is being done. It's a very active project, and we're getting closer and closer to a core set of overlays and game code that is completely decompiled. You can see more on GitHub, and if you're interested, join the Discord server where people are talking about what they're finding and learning and how to decompile. Thanks.